Consider the function f with a domain of -infinity to 3 for f of x equals 2 times log e of 3 subtract x. For part A, we're asked to evaluate f dashed, the derivative, when x is equal to 2. So first of all, we could calculate the derivative f dashed of x. So that's going to equal, and this 2 that's multiplying the function log e of 3 subtract x is still going to be present in the derivative. So we're going to have 2 times, and then if we just differentiate log e of 3 subtract x, we know to differentiate a log, we differentiate the inner bit, so 3 subtract x has a derivative of -1. We put that on the top line of a fraction, and then we divide by whatever's inside the log, so in this case 3 subtract x. So therefore, f dashed of x is going to equal 2 times -1 gives -2 on the top line, divided by 3 subtract x. So that's an expression for our derivative. However, we were asked to calculate f dashed of 2, so we need to substitute 2 into here. So we'd have -2 divided by 3 subtract 2 on the bottom line. So therefore, f dashed of 2 is going to equal -2 divided by, and on the bottom line that's going to be 1. So we're just going to get -2. So that is the answer to part A of this question. For part B, it says, hence determine the equation of a tangent drawn to the curve of y equals f of x when x is equal to 2. So when we want to determine the equation of a straight line, which is what that tangent line will be, we need to know 2 things about it. We need to know a gradient and a point that it passes through. Luckily, what we found above here is really the gradient of a tangent line when x equals 2. So now what we need to do is determine the coordinate of a point that this tangent line goes through. So we could find the value of the function when x is 2. So f of 2 is simply going to equal 2 times log e, and where there's an x, we're going to replace it with 2. So inside the log, we'll have 3 subtract 2. So that is equal to 2 times log e of 1. And we know that log e of 1 is simply 0, so we have 2 times 0, which equals 0. So therefore, we've got the coordinate point when x is 2, y is 0. So now we're ready to find the equation of a line with a gradient of -2. That's what we found in part A, passing through the point that was 2, 0. So to do that, we can use the formula y take y1 equals m times x subtract x1. So that formula allows you to calculate a line with a known gradient and a known point on it. So therefore we'd have y subtract 0 is equal to the gradient, which we knew was -2, times x subtract 2. And cleaning that up, we have simply y on the left hand side is equal to, and we can expand this bracket and we get -2x plus 4. So that is the equation of a tangent line drawn to the curve of y equals f of x when x is equal to 2.